Inside a rocket engine, temperatures can reach thousands of degrees Celsius, hot enough to melt ordinary metals in seconds. Yet somehow, the nozzle survives. The gas rushing through this metal structure can approach 3,000 degrees Celsius. So why doesn't the nozzle simply melt? The answer isn't one magical material. It's a combination of cooling, materials, geometry, and incredibly precise engineering. A rocket engine works by burning fuel and oxidizer inside a combustion chamber. The resulting gases become extremely hot and highly pressurized. They then accelerate through the throat and expand through the nozzle, creating the high-speed exhaust that produces thrust. The nozzle is therefore sitting directly in the path of some of the hottest gases in the entire engine. And the most critical region is the throat, the narrow section where the gas reaches enormous speeds and heat transfer becomes a major engineering problem. If the wall becomes too hot, it can lose strength, deform, erode, or fail. So engineers have developed several different ways to keep the nozzle alive. The first major secret is regenerative cooling. Instead of allowing the nozzle wall to absorb all the heat, engineers circulate a propellant through tiny channels built directly into the engine wall. Think of it like a microscopic network of cooling pipes. Before the fuel enters the combustion chamber, part of it travels through passages around the hot chamber and nozzle. As it flows, it absorbs heat from the metal wall. This creates an incredible exchange. The same propellant that will eventually be burned is first used to protect the engine from the heat produced by that combustion. NASA describes regenerative cooling as a key technique for liquid rocket engines, with coolant flowing through passages in the chamber and nozzle to prevent the walls from reaching damaging temperatures. Cooling alone isn't enough. The nozzle also needs materials capable of surviving extreme temperature, pressure, vibration, and chemical attack. Different parts of a rocket engine can require completely different materials. Copper alloys can be useful where heat must move rapidly through the wall. High-strength alloys can provide structural strength, and composite materials can survive temperatures that would be extremely difficult for conventional metals. NASA has developed materials such as GRCOP42 copper alloy for regeneratively cooled combustion chambers. Modern rocket hardware can also combine multiple materials in a single thrust chamber assembly. In some designs, engineers also use ablative materials. Instead of trying to keep the surface completely unchanged, the material is designed to gradually decompose and carry heat away during operation.